Now that we've spent some time talking about electric fields and electric potential, our next topic will be electric circuits, and we're going to bridge from the one to the other by talking about capacitance. So, let's first take a look at this simulation on the PHYS website, which is from the University of Colorado. This is a metal plate, and this is another metal plate. And as you've seen in the last couple of weeks, we'd like to study what would happen if we charge one of them up positively and the other one up negatively and put them near each other, and we would get a constant electric field between the two. And that could be used for things like, well, as a particle accelerator is the example we've been talking about. Another thing you could do with it is use it as a circuit component, and that's what we're going to take a look at here. This is a battery. And for our purposes, we are going to not get very much into how batteries work, other than to say that there is a chemical reaction on the inside of the battery that provides a 1.5 volt, in this case, that's what a D cell or a AA or AAA batteries have, is 1.5 volts. Of course, other batteries could have different amounts, but 1.5 volts of difference in potential between the top and bottom terminals of this battery. So if I were to connect the top and bottom of the plates to the top and bottom of the battery, we would see that the charge from the top of the battery is able to move into this plate, and then the charge from the bottom of the battery is able to move into this plate. So now the plate itself has a voltage of 1.5 volts from the top to the bottom. When we talk about circuits, the function of a battery will be to provide electrical power, and we'll talk about what that means, but what we really want to know is that it will provide a voltage. That is its function, is to provide a certain amount of voltage that will be used by a circuit. The purpose of a capacitor in a circuit, like the ones that we see in the top right of this video right here, is that they are able to store charge, and therefore they are able to store energy in the electric field between the charges. The amount of charge that a capacitor can store depends on how the capacitor is built and the voltage that you apply to the capacitor. According to this equation, where the term C in this equation is called the capacitance of a particular arrangement of plates. The capacitance is defined by certain physical properties of the capacitor, including the distance between the plates and the surface area of the plates. That kappa that is in the equation has to do with what is in between the plates, and we'll talk about that a little bit in just a moment. And then that epsilon naught is actually a constant of the universe, much like big G in gravitational equation or little k in the Coulomb's law equation. So it's just a constant that you would find to put in anytime you needed to use this equation. In order to make a capacitor smaller, so that it fits into a smaller space when you are building a circuit, they can be rolled up into cylinders. We don't really care if that happens. We can still analyze them as just two parallel plates. But I want you to know what they look like. They look like discs or cylinders in most cases. And I will refer to them continuously as still two parallel plates. That's just a short video to introduce the idea of what a capacitor is. In the next video, we'll talk about how you can modify them with that kappa, and then we'll do a couple of videos talking about how we use them.